Hello and welcome to another episode of Modular in a Week. So this new season, whatever, we started off quite big with the mutable instrument braids in the last episode, if you didn't see that. Today I'm going to make another mutable instruments module, one that I think has been neglected a bit. It isn't talked about that much, but is a very versatile module, and that is the Beaks, or the one we're going to make today, the Beaks. So this is a utility module and a drum module. So it's an LFO, it's an ADSR, it's drums, bass drums, snare drum, hi-hats. It's a four-step sequencer. It's tap. Yeah, it's so much. This one, you need at least two, at least five. I don't know. You need a lot of these in your arsenal because they can be so much. If you want an AD or two ADs, so you can actually split it so you have two ADs or one ADSR, or actually two ADSRs. It's amazing. It's an amazing module. Really like it. We are going to make this with a simpler version, again using the STM32 little module here on the back. Matthias Levy made a version of this which he calls $Beaks, so Beaks, and this is that exact code. What I've done, I've just made a sandwiched version of that. So this is not that many components at all, except for the components up here. There's one op amp and a few resistors, capacitors, two transistors, and one power regulator. So that's it. And of course the STM32. So this is a really simple module that you can make on breadboard, stripboard, anything like that. Matthias Levy did that, and I just simplified it a bit more by making a sandwiched version of this. Because this is Mutable Instruments, Emily Gillet, she made everything open source, so of course this is also open source, so all the files for this and Matthias Levy's firmware can be found on GitHub. Links are in the description. So let's go, let's see how we build this, what we need, and what we can do with it. As with the previous module, braids, the Beaks is also done by Mutable Instruments, and on mutableinstruments.net you can read all about it, a Swiss Army knife for percussive patches. So DivKid has made a really good presentation video for it. If you want to know the functions of this module, you should watch this video. He does a great job showing all the features and all the extra stuff you can do with this module. So I'm just going to show you how to make a DIY version very cheaply. So, and then you watch this video for how to use it. There's some information here. You have hacking resources, and you go, if you want to make the real one, you can do that, of course. Here's the schematics for the original version. So this is not with the one we are going to use because we are not using the DAC, for example. So instead we are going to use Matthias Levy's version of this, reversion, that's what he calls it, a reversion of Mutable Instrument Beaks. So he calls his version $Beaks or Speaks, whatever you prefer, and in the hardware design we have the schematics down here somewhere, schematics.pdf. So this is the schematics that I used when I redrew his schematics here just to make the PCBs. So basically you don't need the PCBs, you can just use this schematics and make your own version just like he has done here. What I've done one step further is I've made a sandwich, a PCB version of his Beaks. So here you can download the Gerber files for the back PCB, the front PCB with all the controls and the panel. With that said, I also found another one. Pan Sapiens did the blue Beaks, which actually seems to be a 3D printed version of Matthias Levy's Beaks. So there's loads of ways of doing the Beaks in a cost-effective way. I say because you can use this module for so much. So download the Gerber files and order 5 of them, and I think you could easily make use of all 5 of them in your patches. Again, from the last video, the braids, I showed that you need the STM32 programmer. I'll put the link in the description in this video as well. And in the DIY through-hole MI braids video, I go through quickly how to plug it into the ST-Link programmer and how to download or upload the program. So there were a discussion in the last episode about whether the STM32 F103C8T6 worked or not. I said you need the CBT6, but this comment right here by Mario BV put a bit of more information on the topic. So it's in short, it says that the STM F103C8T6, so the one I call the 64K version, should work in almost all cases, because the CBT6 is just the endurance of the half-life of the flash for those dies. That should be the difference. And I've tried this. I've bought multiple of these now, and they all seem to work. So so far you can buy a C8T6, that's the important, or CBT6. They don't exist that often and is super expensive, so try the C8T6. And of course you also need a programmer if you don't have that. For way more resources, there is my Discord server with the MITHPWM Beaks channel. Here we discuss this in length, and you see there is a few people who have started building this, and they find these little quirks and errors in my silk screen. So I'm going to update the Gerbers with these fixes to easier find out which part it is you're trying to place. And finally, as I said, I do have a few of these in my shop if you don't feel like ordering yourself from a PCB manufacturer. You can buy a set like this with all 3 PCBs for $9. You can choose if you want the buttons here, the trig buttons is a bit special, or not special, but so I have the blue buttons. They cost around $2 each, but for reasons I don't know why, something got wrong with my order for the green and red ones, so I got way more than I needed, or actually ordered, so I can actually sell them off a lot cheaper than they actually are. And in this button set I also add these buttons here for the split and the mode, which I'll show in a bit, is a bit special. There is a kit coming, hopefully when I release this video. You can also buy a full kit with all the components So that is good to know. Right, let's look a bit on the hardware. This module, just like the other one, uses 3 PCBs, as I've already said. The panel, the front PCB where all the controls are, and then the back where all the other stuff, all the components is. So here's the component kit, all the parts that you need, and then the buttons I'll show in a bit here. And then of course on the back side you add the STM32. So technically you have 4 PCBs if you count this one as one as well. And this is the end result for that. And I'd say it is just about skiff friendly. There's a few millimeters free from 5 centimeters there. So it should be work in a skiff. So one of the differences is the button. The button used in the original, I believe, is a soft button, so you can push it in a bit further than you can this one. This is a momentary. As you can see here, there's no traveling distance on this. And that's, well, it's a price issue, this one, and also this one. In my GitHub, there's also a boom bill of material with all the components on LCSC. So you can buy all these components on LCSC if you buy your PCBs from JLC PCB. So just to make everything a kit and make it even cheaper, because if you buy together you get discounts and all that. No affiliation, just saying. So these, and that's the kit. So you get these 2 buttons, and then these 2 buttons, the buttons that are for the split and the mode buttons, is a bit special as well, because they're those really simple momentary buttons, but they have a really long button. So this is 14 millimeter button. So I add them as well in the button kit, so you know that. And you have that one. And of course you need the programmer. Again, look in my previous video for how to connect this. It's not that much to it. Very simple. And once you have all this, you get this out of it. Not the knobs though. Maybe I'll add the knobs as well as an add-on. We'll see about that. I should do a small explanation for the silk screen on the panel. It is the exact same layout as the original one. I have added a small table to each knob to show you what parameter is set all the time. So depending on what function you have or mode you have different parameters on the 4 knobs. So we have envelope, LFO, tap, drum, sequence, TDEL, TRND, and ADR. And that then, if we go here, I'll show this. This is Paper Noise cheat sheets. I'll put a link to this in the description as well. This shows, it's a very good way of knowing what all the parameters are. So here we have, so this is envelope, then ADSR, and then ADSR split, and that is the second line. So there's 2 lines, one, so if we are in envelope, then this first knob would be attack, the second one would be decay, third one would be sustain, and the fourth one would be release. And then the second row, it says attack, decay, attack, decay. So that's because you have the normal mode, ADSR, and then you have attack, decay, attack, decay. So that's that's that small thing there is this one. And then you have the same for LFO, LFO split, tap, tap split, drum, drum split, 4-step sequence and split, trig delay, so that's the T-del, trig delay and trig random, tap and trig random split, and alternate drum, ADR. So that's what these little things are here. Very useful until you've mastered this here cheat. Those are really good to have handy. I should show you how to put the correct firmware on the chip though. So to get to the firmware, you need to actually download this file. So you press you go into Matthias Levy, Beaks on GitHub, press the green code here, and then you download the zip file, and that way you will download this whole branch. In this file, you open up and in Beaks, and then you go into firmware, and then you go into build. And again, here you have the Beaks 2. This is Dead Man's Catch, the complete firmware, and Beaks is the normal Beaks firmware. And here you have the hex file. You put the hex file on your desktop or some other good place. You then go into STM Programmer. You browse for that hex file. You have it here. And then we connect our programmer. There we have it. This is a 64K STM32 F103 C8T6. That's as it should be. And we have that, and we start programming, and that should do it. File download verified successfully. And that's how simple it is to get the code onto the STM32. Again, look in my previous video for how to hook it up if you are unsure about that. So here I'm using it in advanced mode. There is a trig in on trig 1, and there I have it on trig 1. I have drum, so that's the bass drum you hear. Is the Beaks, but then also I have on the second channel, there's no input. This is just now running as an LFO and using that to control the pitch of the braids. So that's the other sound you hear in the background. And so with one module I have both an LFO and a bass drum. So again, I'm not going to go through this more than this. The DivKid video makes a great explanation for that. Link in the description and maybe up here in the corner somewhere. Alright, that's it for this video. I would like to do a huge shout out to my Patreons who support me through all this, and even the time when I didn't do anything. So thank you guys, you are amazing. And everyone else, if you haven't joined the Discord, there is loads of information there, and no need to be a Patreon for that. Just join the Discord. Make some Beaks, make some Beaks. This is an awesome module. Watch the DivKid video to check out all the cool stuff you can do with this. Download the cheat sheet, very good to have around, and well, just use this in your setup. It's one of those modules I haven't heard so much about. All the Mutable instruments modules, they're all so nice and they talk so much about them, but I haven't heard so much about the Beaks. But for me, it's a really nice module. So yeah, with that said, I'll see you in the next episode. Take care. Bye.